Okay, today let's continue to talk about this unit. Section D, solving logarithmic equations. So, if the log function is a given, and there's an x inside of this equation, we're trying to solve for x. The first step, we need to convert from the log function to exponential function. How we convert from a log to exponential? The first, show you example here. If I have a log with a base b and x here, which equal to y, when I convert this to exponential, first step, you have to keep your base b no change. So we still have a b power something. And then we need to switch these two terms. And then we put y on the power and then put x on the other side. So make sure the base b will not be changed. You still have this b here. You just switch these two terms out. Okay, that's how we convert from the log function to exponential function. So look at 49. And the base is a 5. So we still keep this base 5, no change. And then when we switch these two terms around, the 2 will be power and equal to 2x plus 5. That's the first step. And after we have this step, let's simplify a little bit. 5 squared is 25. And then we still have a 2x plus 5. And now we need to solve for x, so we're trying to get x by itself. So we minus 5, and then make it be 20 equal to 2x. And then divide by x. So x will be 10. And that's it. That's how we solve x for this. Okay, let's try a couple more. 50. Same thing. We keep the base, no change. And switch these two things. So 4 will be here. 4x will be here. And the 3 power 4 is 81. And then we solve for x. So we add 7 on both sides. Make this be 88. And then divide by 4. So your answer will be 88 divided by 4. And simplify to 22. Okay. So look at 51. This time, the base is x. So we still keep the x as a base. No matter what's your base, always keep your base no change. And then will be x power 2. And equal to 2x plus 8. This x always be this base. And then the answer on the other side always be your power. So when we have an x squared, you should recognize that's a quadratic function. So let's move around. We move everything to one side of the equation. So I move the 2x and move the 8. And then make the other side equal to 0. And then we solve this quadratic equation by factoring. So we factor this number to 2 and 4. And I need a negative 2. So 4 will be negative. That means x will be from here will be negative 2. From here will be positive 4. But when you get the answer, you have to check both of them to see whether they all works or one of them works or none of them works. First, let's check negative 2. If I plug in negative 2 back to the equation, the base x going to be negative 2. We cannot have a negative number for the base. That's why negative 2 is not the answer. But when we check the 4, positive 4 here, is possible. Positive number here also is okay. That's why answer only be x equal to 4. Make sure check your answer at the end to make sure which one works. And then look at 52. First thing, exponential. We keep this base 4, no change. And switch these two terms around. So 1/2 will be here. Another side will be x squared minus x plus 2. When we have a power 1/2, you should know that means square root. And the square root of 4 is 2. So we kind of like have a 2 equal to x squared minus x plus 2. Same thing, we move everything to one side of the equation and make the other side equal to 0. So we subtract 2 here and then make x squared minus x and 2 cancel equal to 0. So we factor x out. That means x can be 0 or x can be 1. So we have 2 solutions at this point. So same thing, we need to go back to check. So if I plug in 0 back, 0 minus 0 plus 2, that's a positive number, so it works. When I plug in 1 back, 1 minus 1 is a 0. 0 plus 2 also is a positive number, so both of them work. So we have 2 solutions for this problem. And then look at 53. This one has a little bit different because we have 2 logs. When we have 2 logs, first step, by using property, the one I showed you earlier, let's find out where. Okay, here. When we have a log something plus log something, we can rewrite this to multiplication. When we have a subtraction, we can convert to division. That's a property we're going to use for this question. Okay, let's see. When we have addition, that means we can change to multiplication. So we have a log, no change. And then we have x minus 1 times by 4. And then keep the 2 on the other side, no change. Actually, this is go with the whole thing. We still have a log of this whole stuff. When we have a log by itself, we follow the same rule. We convert to exponential equation. The base for this equation, you can see there's no number here. That means we call this is a common log. When you have a common log, the base should be automatically be 10. And then we convert these 2 things. We put 2 here and put 4 times x minus 1 on the other side. And then let's just solve it. 100 equal to 4x minus 4. So x will be 104 divided by 4. So which will give you 26. So that will be your answer. And you don't have to do 54. That's fine. Oh, we do need to do this one. Okay, I forgot. Sorry. Let's do this. Same thing. When we have a subtraction, that means we can convert to division. We have a log base 6 and 35x plus 6 divided by x and make it equal to 2. And now let's convert this to exponential. Base 6 stays 6. Convert these 2 terms will be 2 here and 35x plus 6 over x. We can simplify 6 squared a little bit, make be 36. When you have something on the denominator, you can cancel this by multiply by this whole thing on both sides. So when we have a 36x equal to on this side, they will cancel. We only left 35x plus 6. That would be easier to solve. Move this to the other side and get the x by itself. Oh no, we move the 35x to this side and then get x by itself. So that x will be 6 and that's it. That's how I solve the 54. And then for the 53, we have additions here, so we can do multiplication. We have a natural log of 2x minus 3 times x plus 4. And the right side, keep natural log of 2x squared plus 15. This time, we don't need to convert your log function to exponential function because we have a log on both sides of the equation. When natural log of something equal to natural log of something, these 2 inside have to be equal to each other, and then we're able to make this equation be true. So you only need to make the inside equal to each other. So there's no log anymore. And you only need to do simplify. let's FOIL these two. That will be 2x squared, and the minus 3x plus 8x, that will be plus 5x. And that would be negative 12. And equal to 2x squared plus 15. And then we move this around. I subtract 2x squared, so I have 5x. And I move this around, so I have 27. And then x will be 27 divided by 5. That's how I work on this. For this one, we have a 1 log on this side and a number on the other side. Also another log on the other side. So there's a multiple way to do it, but the easier way is we move this log over to the left side. We're trying to put all the log on one side of the equation. So I have a log base 2, x squared minus 6x. Subtract log base 2, 1 minus x, and equal to 3. So when we have a subtraction, we should do division. So we have x squared minus 6x over 1 minus x equal to 3. After we get the single log by itself, and we're able to change to exponential. We still have a base 2, so we keep this 2 no change. I highlight this to make you recognize that's the same base. And move this 3 to this side. And the x squared minus 6x over 1 minus x on the other side. So 2 cubed is 8. So 8 equal to a fraction. Like the question we did earlier, when we have a denominator, you just multiply by this denominator on both sides. Okay, and then let's distribute this. That will be a minus ax. For the right side, that will be canceled. So we have x squared minus 6x. So let's move these two terms to the other side. So I have x squared minus 6x and the plus ax minus a equal to 0. And the combined like term, so that would be x squared. This would be plus 2x and the minus a equal to 0. And the quadratic equation again. So when you have a quadratic equation, you can factor this. So negative a, 2 and 4. We need a positive 2, so this number will be negative. That means x going to be from here is positive 2. From here will be negative 4. Also, don't forget to check your answer. If I plug in 2 back, 2 squared is 4. 4 minus 12. You will get a negative number. Okay? We cannot have a negative number here. That's why this is not answer. Let's check negative 4. When we plug in negative 4, this will give you 16 plus 24. And that may be positive, so it's okay. And let's try the other log. When I'm using negative 4 here, that will be 1 minus negative 4, that will be positive 5. Also, it's a positive number. Also, it's work. That means the answer for this problem going to be negative 4. That's how we solve the logarithmic equation. This type of the question on the test also will be non-calculator. Okay? That's how we do part D. Now, let's do part E, solving exponential equation. We did the solving exponential equation earlier. If you, let's see, find the notes. If you still, okay, here. If you still remember how to do this, when we solve this equation, we try to change them to same base, and then make power equal to each other. But this question, 3x equal to 12. There's no way to change 12 to base 3. So for this type of the questions, if you can now change them to same base, you're able to use a calculator to find the answer. Okay, look at 55. This is x, if you can see. Okay. There's two ways. First way, we change this equation to the log. So we keep this base 3, no change. And that would be log base 3. And we flip this two part. That will be 12 here and the x on the other side. X will be on the other side. And now let's use our calculator. There are some options in the calculator. You can just do alpha window. And there's a log 5. So let's type the base 3. And let's put the 12 here. And then you will get answer. So x will be 2.262. Let's keep 3 decimal places. So that's the first way. Second way, okay, we have 3 power x equal to 12. We can take common log or natural log on both sides of the equation. If I'm doing common log, okay, so I will have common log of 3 equal to common log of 12. No, common log of 3 power x. And by using the power rule, if you still remember what's a power rule, let's find that paper. Where's that paper? Here. When we have a power here, you can just move this power to the front and to put this number in front of this log a. Okay, so we can do this one too. When there's a power, I can move this to the front. So be x times log base 3 and equal to log 12. And now we're trying to get x by itself. So we're just using log 12 divided by log 3. Okay, let's check our answer. So if it's a common log, there's a bottom. Okay, will be here. So be log 12, close, divide by log 3. And then we're able to have the same answer. Okay. Also, if you want to do natural log, okay, I want to do natural log here. It doesn't matter. I will have x times natural log of 3 equal to natural log of 12, and my x will be natural log of 12 over natural log of 3. Okay, let's check our answer again by using natural log. Natural log on the calculator will be here. So it will be natural log 12 divided by natural log of 3. You have the same answer again. So it doesn't matter. This way, this way, this way. Answer will be same. Okay, let's do one more for 56. If I want to change this to log, I keep the base 3.4, no change. And then convert these two things. I put 29.6 here. And then make equal to the exponent x plus 4. And if I want to solve for x, I just need to minus 4 on both sides. When you subtract 4 from a log, don't subtract 4 from 29.6, because log of this number, that's one number. They attach to each other. You have to subtract 4 from this whole thing. And then let's use the calculator. So alpha, window, and 5. So base is 3.4. Inside will be 29.6. And remember to close, I already have this. Okay, see, we already have parentheses here. And then subtract 4. So that would be your answer. Answer would be negative 1.232. We have a negative as the answer. When you plug in back, the negative number will be on the exponent. It's okay to have a negative exponent. Just it's not okay to have a log of a negative number. But it's okay to have an exponent be negative. That's how we do that one. Okay, let's do two more. For 57, this one, you cannot take log first because we have some leading coefficient in front. So for this type of the question, you have to cancel this number before you take log. And then cancel this. We have 10,000 divided by 4,000. And this will be 2.5. So 2.5 equal to 1.06 power x. Okay, now I'm going to do the other way. So I take a log on both sides. And you can move the x to the front. So we have x times log 1.06 equal to log of 2.5. And the x will be log 2.5 divided by log of 1.06. And then you can type to your calculator again. So log 2.5 divided by log 1.06, and which would be 15.725. Okay, that's how you do this one if you have a coefficient in front. Okay, let's do one with the e. For 62, this one has a little bit special. It's not just to have a 3 in front. We also have an 8 in front. So we do same thing. We need to get rid of this 8 first by subtract 8 on both sides. So I have a negative 3 times e power 4x plus 1, and equal to negative 8 plus 2, that will be negative 6. And the next step, I need to get rid of the negative 3. So we need to divide by negative 3 on both sides. So that would be e power 4x plus 1 equal to negative 6 over negative 3 is 2. That's the one we need to take log on both sides. You can do common log, or you can just do natural log. I'm using natural log for this because I have a base e that makes my question more easier. So if I do natural log here, when these are same, that will tend to 1. Whatever you let from the exponent, that's going to be what you have. And for the right side, we still have a natural log of 2. So when we solve for x, we minus 1 and divide it by 4. You can, if you want to stop at this step, it's fine. That'll be your answer. Or we can just change to decimal. Will be natural log. Okay, let's change to fraction. There will be natural log of 2. Close the parentheses and subtract 1. Divided by 4. So this will give you negative 0.077. I just round up. Okay, so that's how you get the answer. That's how you solve the exponential function if you cannot change base. I'm using natural log for this problem because the base is e. That makes my question easier. If you want to use a common log, you still can do so. Your work might be a little bit different, but your final answer will stay the same. Okay, that's how we solve the exponential equation and solve the log function. That will be what on the first test. So the first test will be 2 sections. One is a calculator allowed. One is a no calculator. And for the calculator allowed question, this will be calculator allowed. This one will be calculator allowed. And also there one more, also will be calculator allowed. The change base formula. The change base formula also will be calculator allowed. So these 2 things will be on the calculator allowed questions. All the rest problem will be no calculator. So make sure you know how to do this power by yourself. If you have a fraction as a power, how to do it. If you have a negative power, what that means. Okay, that's what you need to know. Also, you have to really know those properties. And after you use a property, you have to keep going to simplify until you got a number. You cannot stop here. You have to keep going to simplify as much as you can. Okay? If you stopped here, I will give you partial credit. And there's a practice quiz on its learning. One is blank, another one with my color notes on it. So I want you try to solve every single problem by yourself first without looking at the notes. And then use the notes to check your work. And if you still have a question, let me know. And when you get it ready, also it's time to take the Unit 3 Test 1. Okay, I think time. Okay, I'm going to show you the second part also. The second part will be the word problem. And the exponential growth or decay. So we still talk about exponential equation, like the graph we did first time. If the graph get increase, that means the base b will be greater than 1. And the y value will be getting larger, and until a point it will be getting larger faster and faster. When the function is decreasing, that means the base b is less than 1 and greater than 0. Make sure we cannot have a negative number as a base. And when the graph is decreasing, so we start from this y value and decreasing really fast at the beginning until somehow and will be decreasing slower and slower until approaches to something, but never be 0. There's no way make the y value equal to 0 for the exponential. And when you have increasing, we call this type of the function is exponential growth. When it's decreasing, we call that a decay. And you can read all those introduction by yourself and to understand more. And I just show you how to do the problem. When we have exponential growth and the decay, there's a formula you're able to use. And you need to remember these two formulas. On the test, I'm not giving you these two formulas. But these two formulas, only one thing different is, one is addition. And one is a subtraction. That actually would be really easily to understand. When we have exponential growth, you know your y value is going to be bigger and bigger. That's why we do addition. When we have exponential decay, the y value is going to be smaller. That's why we do subtraction. So that's only one thing different. Now look at this formula. You need to know what those values represent. So first, p sub 0. We call this value is initial population. That's how much you have at the beginning when t equal to 0. Okay, and we call that initial. R, that's a rate of change. Usually we're given as a percent. So make sure you have to convert from percentage to decimal. And for example, if I have a 2.5%, this actually will change to 0.025. Okay, make sure you know how to convert to decimal. And when you convert to decimal, that's a number you're going to plug into the formula, not 2.5 anymore. Will be this decimal. And next one, n. N is the number of the time period it takes for the rate R to occur. So if we have every minute, that means n is 1. If we have every 2 days, that makes n be 2. If we have every half year, that will be 1/2. Okay, this n, value of the n, actually from here. So you need to read the question carefully to figure out what's the value of the n. And the t will be the time. And the unit of the time t can be seconds, minutes, hours, or day. And if if you use for the calculator, if you're using calculator, the t value actually will be your x. And this P is what initial value you solve for. Actually, this will be P of T. That means you're looking for what's a population at a certain time T. And this one actually will be represented by Y value on the calculator. So this is Y, the T going to be X. And the same thing for the decay. That's what these two formulas recognize. And now let's look at the problem. For this question, first thing, you can highlight what are given, what are necessary number you need to know to plug into the equation. So for this one, we know this one. So you can know that's going to be R. So R is 0.03. And the change from percent to decimal. And a year, that will tell you N is 1. And its current cost is $125. So that would be our initial price. That's all we know from the problem. Now we can write the equations. So be P of T is equal to initial 125 times 1 plus 0.03 and the power T over N. So that would be T over 1. So that would be equation. And for part B, we draw the graph that show cost of this car over a 10 years period. Okay, so when you graph, I'll show you. First thing, go to Y. And let's type this equation. So 125 times 1.03 power X. That's how you type the equation. But before you graph, okay, let's say if I graph, I see nothing here. That means I have to change my window. Okay, how I change my window? Look at this question again. We need first 10 years. That means we always start from 0 because there's no negative T. There's no negative T. So actually, your scales, the X minimum will be 0. And the X maximum will be 10 because that's what the question asks for. So this number always tell you the X maximum. Okay. And now let's look at the Y. Y value we also start from 0 because we don't have a negative populations. So we also start from 0. But what's the Y maximum value we should use so you're able to see the complete graph? We are looking for the first 10 years. So for this value, you have to plug in 10 to your population equation to figure out what's the Y value at T equal to 10. So let's do this one. 125 times 1.03 power T is 10. Oh no, power 10. So that will be number you're using for your Y maximum. And then you can run a little bit. You have to have a number at least be, it's hard to see. Okay, here. You need to find a number at least be this value. So we have a 167.9 something, so I can run at 168 to make it easier to type in. Okay, so that's Y maximum. Now let's go to window to change everything. 0, 10, 0, 168. And now you graph. Okay, so your graph looks like a little bit like a linear equation, but actually it's not linear. Why does it look like really straight? Because the base is a 1.03. It's really close to 1. That's why this curve, they still curve, but it looks like a little bit more flat. So we start from here because that's our initial price, 125. And we still have a curve, but a little bit more flat and going up until goes to this point. That's how you graph, and that's how you change the window. Okay, now look at part C. Find the projected price for T's clean in 5 years. So this number will give you T equal to 5. So what you need to do is just plug in 5 to the functions. And there's two ways. You can just do 125 times 1.03 power 5 to get the answer. Another way, if you don't want to retype this function, we already have a y1 here. So you can just do alpha trace, and that will be y1. And the parenthesis, put your t, enter. You will get exact same number. This way will be spend less time on it. So answer will be 144.9 something. So I can run as a 145. Oh, you can have a decimal. It's okay because we talk about the price. It's okay to have a price. But when we talk about population, you have to run to whole number. Okay. Look at the last one. How long? So we are solving for t. And we take for the price to be $200. So we know the price is a 200. That means we know P of T is 200. So you need to write down 200 on the left side and keep what you have on the right side. And we're solving what a T is. Are you still familiar with this equation? That's the exponential equation I just went over for minutes ago. See if I still have it. Okay, why I don't have it? Oh, here, right here. When we have this exponential, we solve for this exponent. That's how we do it. We cancel the coefficient and then take log on both sides. Okay, let's do it. Oh, it's right here. We divide it by 125. Okay, so we have 200 divided by 125, which is 1.6, and equal to 1.03 power t. And then I take log on both sides to make the log of 1.6 equal to t power log of 1.03. And when I solve for t, I just divide by this log 1.03. And then you're able to get the answer. So log 1.6 divided by log 1.03. So answer would be 15.9, and the t, the unit of the t will be year. So it takes 15.9 years, so almost 16 years to get $200. That's what we work on for this exponential growth. And let's try a little bit more. The back page, number 2. Number 2 has a little bit different because we still know 1,000, okay? And then the R, we don't know the R. The question said the value, the population, we get a double. Kind of like if I have a $1, the double would be $2. And compare $2 and $1, how much increased by? We increased by $1, right? So that's why when we talk about the R, that's not 200%. That's just be 100% because we increased by 100 to get the 200%. That's a different compared to last time. So N for this one, every hour so will be 1 again. And then, so we have equation is 1,000 times 1 plus 1. So this actually gives you 1. So 1 plus 1 and the power t. Actually, that's how we get double, because 1 plus 1 is 2. And that's how we get the equation. Same thing, when you graph, x is from 0 to 12. Y value is from 0 to P12. Okay. And then you can just graph. Okay. For the C, 8 hours, 15 minutes. The T is not 8.15, because if you want to use it hours, you have to convert from 15 minutes to hours. How we convert minutes to hour? We're using 15 divided by 60. So that means the T is equal to 15 divided by 60. That will be 0.25. So we have 8.25 hours. And that's the T you are using. Okay. So we plug in this T to the equation. And using our calculator, that's how you get the answer. Okay, look at part D. When this vector will be 1 million, so we have a 1 million, so 60. And then make it equal to this equation, 1,000, and the 2 power t. So same thing, we divide by 1,000. So make it be 1,000 equal to 2 power t. And we do log. So t move to the front. Actually, t will equal to log 1,000 over log of 2. And that will give you answer. And you can calculate by yourself. Okay, let's try one more. Let's do number 4. For the number 4, this will be the initial. And this will be your R. So when I change to decimal, that will be 0.1268. And the N, every 4 years. That means N is 4. Okay, now let's write the equation. P of T is 5,000 times 1 plus. We still do plus because it still grows. If it said decline or decreasing, some other words means decreasing, you need to use a subtraction. But this one we still do using plus. And the power t divided by 4, not t anymore, because n is 4 this time. And now let's graph. During the 20th century, okay, this time a little bit different because we make year 1900 as your 0. If 1900 is 0, 20th century, that will be 1,000. You need to find the difference between your starting time and your ending time. And for the y value, same thing, we plug in 1,000 to your equation. You're able to get your y maximum. And your graph will be look like increasing again. Okay. For C, we're looking for the population in the year 2008. So you need to find out what's the difference between 1900 and 2008 to figure out what's the value of the t. This will be 108. So that's the number you plug into your equation. Okay. And then to get your answer. Make sure when you get your answer. Okay, let's do this together. So 5,000 times 1268 power 108 divided by 4. Don't forget divide by 4. And enter. We cannot have a decimal population, so that's why you have to take this decimal off. The answer will be 1, 2, 5, 5, 5, 5, and the people. That's how we do it. And let's do one more. D. Determine method when. So we're solving for time again. And we have this at the end. So 17,510 equal to, write your equation, 5,000. And then we divide by 5,000. So this will give you that'll be 35 equal to 1.1268 power t over 2. And then we can take log again. So that would be t over 4 is equal to log 35 over log 1.1268. And when you get this answer, you just need to multiply by this answer by 4. And that's how you get it. You get this? Okay, one more thing I want to mention. So, for example, if your graph will be decreasing, if your graph is decreasing, the x minimum is still 0, x maximum depends on what they ask for. So, for example, if also 10 years, so that's still 10. But y maximum value, you are not plugging any number to the equation. Excuse me. The y maximum value will be your initial. That will be your initial population because the value going down, that's why the starting point will be your maximum. So just use your initial value from the problem. You don't have to plug in any number to figure out what this value is. Just the initial. That's only different for the decreasing. That's how we do decay and growth. And also, you need to finish the homework page. And let's do, there's one more thing, I think. Somewhere. Oh, here. Next page. Half year. First, our population function is this one. That's the equation we're using for exponential growth and decay. If we have a half-life problem, only thing different is half-life means the value going to be reduced half. You just need to change this whole thing to 0.5. So the equation for half-life problem will be initial 0.5 power t over n. They won't give you r anymore. You're always using 0.5 inside. And you have the same thing on the outside. The n will tell you how many time period will take this half-life. So that's only one thing different if you have a half-life. And do same thing for the other part. I think we can do the last part. Last part actually is pretty easy. Because last part is the formula will be given. This formula will be given on the test. And you need to read, I need you to read this part. When we talk about exponential growth in the financial field. And that's how show you how we do the compound interest and the low stuff. So I need you to read this and read this. Okay. And now I just show how to solve the problem. That's the equation I given when we talk about the compound interest. Okay. Also, let's look at what those values represent. The P sub 0, same thing, initial. And the R is annual percentage rate. We call it APR. That's what the bank call it, APR. Always means annual percentage rate. And that means the unit of the T going to be year all the time. If you are not given by year, you have to convert your time to year. Last thing important is N. And also it's a number of compounding interest. So if the bank will compound your interest like every 2 years. Every 2 years. That means for each year, the bank actually only compound your interest half of them. That's why N will be 0.5. If they're going to do interest once a year, that means you only did it once. That's why N is 1. If you do twice a year, that means you do 2 times. If you do every 3 months, how many months we have? 12. You do 3 months, that means you're going to do 4 times. That's why N is 4. Every month will be 12. Every week will be 52. Every day will be 365. If I'm looking for every hours, you just using 364 multiplied by 24 hours because we have 24 hours a day. If we have average minutes, that just be this number multiplied by 60 because you have 60 minutes per hour. So you do need to know this. Biannually, annually, semi-annually, quarterly, monthly, weekly, daily. You do need to know this. This won't be given on the test, but this formula will be given at all. Let's do one question. Leave the formula here. So next page. If you invested $5,000 in bank, so that will be P sub 0. And given 400 APR, so that's your R, and you change this to 0.04. And for 10 years, so we know T is 10. So look at the part 1. If we compound this biannually, that means N is equal to 0.5. So when you plug in this to your equation, will be initial 5,000. 1 plus 0.04 over N is 0.5. And the power N is 0.5 times T is 10. And the user calculate get the answer. Make sure show this equation on the test. And let's do monthly. Monthly means N equal to 12. So we still have a 5,000. And the 1 plus 0.04 over 12. And the power 12 times 10. And then get the answer. That's how you do this regular compound interest. And if your N is getting larger and larger and larger, those values going to be stay the same. After you calculate all this, you will realize that when this N getting bigger, the principal will getting bigger, bigger, and bigger, and they almost be same. So when this N getting larger, we don't do N anymore. The value of the N doesn't matter for your answer. We call it continuous compounding. If it's continuous, that means we follow another different formula. This formula also will be given on the test. And look at this one. P sub 0, that's still initial. E, that's just the E. You can find this on the calculator. And the R is APR. And then T. You will realize there's no N for this formula anymore. Okay? So for the number 7, let's try this. We still have the same question of the number 6. So initial still 5,000. And the E, power 0.04 times by T. Okay. T, we still have the question number 6, which is 10 years. So we're still using 10 years. And that's what the answer you get. Okay. After you do this answer actually will be similar to this answer. That's why when the N is really big enough, you always will have the same principle. The N value doesn't matter anymore. Okay, that's how we're doing that. And then you can practice more to do the homework. I need you to finish all the homework. And then we also did IXL today. It's F16 and F17 on the Precal. I need you to make 80% SMART score to get 100. And there one more thing we left is I need to show you how to do the scatter plot on the calculator. So I might need to give you another video next week that will go with this test. This will be test 2. The student will take this test on Monday. So when you're ready to take your test 1, let me know. After you've done test 1, you're able to do test 2. I want you to finish these both tests by next Friday. So you're able to take your final semester exam with all the other students on next week, Tuesday. That's December 17th, I think. And they will take tests start at like 8 or 8:15 right after announcement. And then the test will take 2 hours. I will email you the test by 8 o'clock, and then you just do it. And then when you're done, I want you send me back immediately. Kind of like I give you 2 hours to do it. Okay, if you have any question, email me.